Hey guys, welcome back to AlgoYogi. We are doing two pointers series and we just moved on to the medium level questions. And our second medium level question in the list is remove duplicates from sorted array second, King George II. All right, let's go through the description. Okay. So given an integer array num sorted in non-decreasing order, means increasing order but not strictly increasing order, remove some duplicates in place such that each unique element appears at most twice. We have done a problem like that where we were removing all the duplicates. Here we are allowing duplicates at most twice. So if something occurs more than 2 times, then we only keep the 2 occurrences and remove everything else, okay, of that particular element, not everything else. So the relative order of the elements should be kept same. Since it's impossible to change the length of the array in some languages, you must instead have, since we are doing it in place, we don't want to mess up with the length of the array. We don't want to return, the updated length of the array. We just want to, what we want to do is, after we get rid of these duplicates more than twice, the elements that are occurring more than twice, what we want to return is, so far we have seen whatever the values that we have seen either once or at most twice, and wherever they end in our final updated array, that's the length we just return, okay? I'm sure you know what I mean by that, because we have done so many problems like that. So more formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final results. We don't care what's after that, just return that k. It does not matter what you leave beyond the first k elements. Okay, same thing, right? So do not allocate extra space. That would have been way easier. You must do this by modifying the input array in place, okay? So no extra memory, big of 1 extra memory, which is constant, okay? To understand this, I think it's a really simple problem. We have done something similar to this, where we were checking, we were starting our iteration at our first index, and then we are checking if this element is same as I minus 1, which is 0th index. If it is, then we basically skip that. We do not basically swap it, so that like whatever you are currently iterating, you keep another pointer that only points to all the basically non-duplicate values. So something like that we have already done. Now let's move on to this logic. I'm not gonna explain out iPad. My iPad is updating, but we will write the code right now and we will understand it really clearly. So what we want to do is, this time, since we can keep at most 2 copies of a particular element, that means, so if you see over this example right here, what we can do is we can keep 2 ones, since there are 3 ones right now. So what I'm going to do is, I'm going to point my ith pointer that will be iterating over this, and my kth pointer pointing to second index. You know why? Because first 2 elements have to be there. Even if they are basically same, then we are allowed to keep at most 2 copies of that. If they were not, then we were more than fine, because single copy is like more than valid, okay? So now what we are going to do in our output is 1 and 1 remains intact, and then this one basically goes away because this is a third copy, and we're gonna check if my ith value is equals to my j minus 1 value. J will be pointing to the same element right now, but later it will be different. However, even in my output, this will make sure that we are checking the remaining values, not the values over here, okay? we want to check it with the remaining values, so that when we return the final output, it does not contain elements more than each element no more than 2 copies of a particular number. In this case we can say, and then in this case here, this one will go away, then 2 does not match with this one and the previous one, so 2 will come over here, second 2 will come over here, and then 3 will come over here. So right now it was just this one that had to be taken out. That's it. Okay, let's write our solution now. So as I said, we're gonna have a k pointer pointing to 2, but you know what, let's make sure we have this edge case where if length of my nums is basically less than 2, that means what, I can just return length nums, right? That's what I return. All right, now what I can do is start my I pointer for I in range. I'm gonna start my loop at 2 as we talked about it. Just gonna zoom in so that it looks nice on the big screen. Okay, and length nums. All right, now what I'm gonna do is if nums I, which is starting at 2, is equals to nums k minus 1. Remember, k is still pointing to the same array, but it's pointing to the updated elements. In the beginning, they're just pointing to the same index, which is 2, but later, given how many repetitive values we see, I will keep moving forward, but k will maintain the index that has all the at most 2 copies of the values. So in the beginning, they're both pointing to k, but now they will be pointing to different values, but we still want to check if my ith value is equals to basically k minus 1, and that is equal to nums k minus 2. If this is the case, we want to not increment, we want to just continue, because loop will basically increment it for us. Otherwise what we will do is nums k, I'm using this k because of the questioning of the problem. Otherwise I like to use j, they are like Tom and Jerry, right? And okay, and then this will be the value coming from nums I, and here we increment k. Okay, now we just return k because that will be pointing to all the updated values where they will be ending. Okay, and I think that is it. Let's zoom out and run it on examples. Works fine, and we're gonna submit it. All right, that's a pretty efficient solution. Let's write the time complexity, which would be big of n, where n is the number of elements in our nums, and space complexity we will write big of 1, because we haven't used any extra space. We're just playing around with 2 pointers. Okay, so it's gonna be like k is here, I is here, and I is moving, and k is also moving, but I is moving faster sometimes, you know, when there are like repetitive values too many times, more than 2 times each value. Okay, right, let's go to AlgoYogi, mark this solved. It didn't require us to explain things on iPad. Okay, all right, let's see you in the next problem. Until then, bye bye.